What does SOLID stand for and what are its principles? SOLID is an acronym that represents five principles of object oriented design that help in creating software that is more understandable, flexible, and maintainable. These principles were introduced by Uncle Bob and are widely regarded as best practices in software engineering. Let's talk about the first thing, which is the S, which will be the singular responsibility principle. In terms of definition, a class should have only one reason to change, meaning it should have only one job or responsibility. The explanation of it, each class should focus on single task or functionality. This makes the class easier to understand, test, and maintain because it encapsulates only a single piece of behavior. Number two, open closed principle. In terms of definition, software entities like class, modules, functions, etc., should be open for execution but closed for modification. The explanation of it, you should be able to add new functionality to a class or module without changing its existing code. This can be achieved through techniques like inheritance, interfaces, and abstract classes. It helps prevent breaks and it helps prevent breaking existing code when new features are added. Number two, we have Liskov substitution principle. The definition objects of a superclass should be replaceable with objects of a subclass without affecting the correctness of the program. An example for this or explanation for this is that driver the classes must be substitutable for their base classes. This means that subclass should override the parent class methods in a way that does not break functionality from a client's point of view. The subclass should not change the expected behavior of the base class. Number four, we have interface segregation principle. Definition of that, like no client should forced to depend on methods it does not use. The explanation is instead of having one large interface with multiple methods, it's better to have several smaller, more specific interfaces. This ensures that implementing classes only need to be concerned with the methods that are relevant to them. Number five, we have deployment inversion principle. The definition of a high level modules should not depend on low level modules. Both both should depend on abstractions like interfaces or abstract classes. Additional abstraction should not depend on details. Details should depend on abstraction. Explanation for that, this principle promotes decoupling by suggesting that both high level and low level modules should depend on abstract interfaces rather than concurrent implementation. This allows for more flexible and maintainable code, as changing the implementation details will not affect the higher level modules. So let's make a summary of the solid principle. The first we talked about a single responsibility is one class has one responsibility. That's it. We have open closed principle. We are open for execution but closed for modification. Number three, we have the list scope substitution principle. Subtypes must be substitutable for their base type. And number four, we have interface segregation principle. Clients should not be forced to depend on interfaces they do not need. And lastly, number five, we have dependency inversion principle. Depend on abstraction, not on concretions. The benefits of the solid principles. Let's talk about the benefits because I guess it's a pretty important to talk about that. The first thing, it will be improved reliability. Code becomes more understandable and easier to follow. Number two, we have enhanced maintainability. Changes in the software are easier to manage and less prone introducing bugs. Number three, we have increased reusability. Well designed decoupled code can be reused across different parts of the application or in different projects. And lastly, we have better testability. Code that adheres to solid principles and generally easier to unit tests because of its modularity and clear separation of concerns. In conclusion, the solid principle provide a robust foundation for designing flexible, maintainable, and scalable object-oriented systems. By following these principles, developers can create software that is easier to understand, extend, and maintain, leading to higher quality and more robust applications. So that's it for this video, and see you in the future.